All right, this is the quiz, practice quiz over sections 2.7 through 3.4 in the Stewart Calculus book. This is the definition of the derivative. F of x plus h minus f of x all over h as h drops to 0. And we're supposed to use this to find the derivative of this. We know that the derivative is 2x plus 3, but I want you to show how to do it using this, this formula right here. So f prime of x is equal to, so this says put x plus h into x, so it's x plus h, quantity squared, plus 3 times x plus h. So where there was an x, I replaced it with x plus h, minus 8. And then minus the whole function. So it's very important that you say minus the whole function. So x squared plus 3x minus 8, because you have to distribute the negative through all of that. All over h. And I forgot something. I forgot to write limit h drops to 0. So that's my bad. I should have had that in there better. So I'll write it again down here. Limit h drops to 0. So we're going to square this out. We've done that enough times. It should be x squared plus 2xh plus h squared. Distribute the 3. 3x plus 3h minus 8. Distribute the negative through. Negative x squared minus 3x plus 8 all over h. You did enough of these that you should know that everything goes away except for terms with h in them. So the x squareds go away, the 3x's go away, the 8's go away, and we're left with 2xh plus h squared plus 3h, and that's right, divided by h, which would be limit h drops to 0. The h divides into all three terms, which is good because then I'm no longer dividing by 0. 2x plus h plus 3 when you do that. H goes in as 0, and you get 2x plus 3, which is f prime of x. All right, which we knew in the beginning, but when I grade this, I'm going to be looking for key things through here. Okay, the next one, you have to identify so this is the other definition. This of the derivative is limit x goes to a at a point, so it's going to be f of x minus f of a divided by x minus a. So we have to state the function and the value of point A. Well, it's x minus a, so that's the place where we're taking the derivative. We're taking the derivative at pi over 3. So a is equal to pi over 3, and the function is right there. Bless me. The function is cosine of x, which makes sense because when you put this into here, you get 1/2, and that's what's sitting up there. So this is the other definition of the derivative. So it's function minus function evaluated at a point, and then x minus the point. All right, next one. When it says write the equation of a tangent line, you always make a table without even thinking. So you got x, f of x, and f prime of x. So, or sometimes we write y or x, y, dy, dx. So x is 0. So I want to, and I know that at 0 the y value is 4. So that's what this tells me, is this is a point. 0, 4 is the point because that's your x value, your output is your y value. And then when you have the derivative here, that's the instantaneous rate of change is at 0, and then you would get 7. So the slope is 7. Now this one is pretty straightforward because 0, 4 is the y-intercept. So you can do y is equal to 7x plus 4, and then you're done. But you could also do point slope form if you didn't have a 0 there. So it's always y minus 4 is equal to slope, which is 7 times x minus 0, and then you could solve that out. But it's the same answer as this. All right, now we're going to be taking a bunch of derivatives. The first derivative, dy dx, is the simple one, right? So power rule, 6x minus 8, derivative of a constant is 0. So that's the answer. Done. Okay, now we're going to do the power rule again, but we're going to do a little pre-treatment here. 2x. Now anytime that I have a constant up here, I always move this to the top and avoid using the quotient rule. So I'm going to change that to -3, like so. So then I'll just say dy dx is equal to 2/3 x to the -1/3, because you subtract 1, minus 3x to the -4. Now we cross the line and change the sign, so it's 2 over 3x to the 1/3 minus 3 over x to the 4th power. Now if we got really fancy with this, we could find a common denominator and subtract the two fractions. Number 6 is the quotient rule. So the quotient rule is what I need to do on this one. So we're going to do bottom squared, which is 3x squared plus 8x, and we square that. We then copy the denominator down, so that would be 3x squared plus 8. Derivative of the top, the numerator is 1, so it just times 1, so it doesn't do anything. Minus derivative of the bottom is 6x plus 8 in parentheses, of course, and then times the top, x plus 3. All right, now we're going to do some simplification on this to make it better, because I think it's worth doing on this one. So it's 3x plus 8. Okay, I'm going to FOIL this out and distribute a negative through it. 3x squared. 6x squared with a negative in front would be negative 6x squared. 6x and 3 would be 18x, so minus 18x. X and 8 would be minus 8x. X and 3 would be 24 with the negative, minus 24. All over 3x squared plus 8x squared. I think it's reasonable when it's a polynomial like this to simplify it down more. So 3x squared and that would be minus 3x squared. The 18 and that go together, so minus, whoops. I lost an x there, didn't I? Caught myself. So that's an x. That's an x. Okay, so that and that cancel out, so minus 18x. Caught my mistake. When I recopied this down, I didn't put an x there. So I needed an x there, and then that and that cancel out. Okay, then this goes here. And then then the 24 is by itself, minus 24. All over 3x squared plus 8x and then squared. All right, you could factor out a -3 to the front, but I'm going to go ahead and leave it there because I just ran out of room myself. Okay, number 7. dy dx. This is open node and open book quiz, so you can look these up if you need to. The derivative of cosine is negative sine, so it's 2 sine x. And then the derivative of tangent, secant squared, derivative of cotangent is negative cosecant squared. So it's -3 cosecant squared x. And that's about all you can really do with that one. Then the next one is chain rule. So I gave you this hint here because you want to think about this as sine x and then squared, like so. So the derivative with respect to x would be derivative of the outside, 2, blah, 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 to the first. Copy. Derivative of the inside, cosine x. So the answer is 2 sine x cosine x. Ba-boom. Okay, and the next one's also chain rule. So this would be dy dx. These are simpler chain rules for the quiz, 4 blah, blah, blah to the 3rd power. And then we copy. Derivative of the inside, 2x plus 3. So I will multiply 4 times that because I think that's okay to leave it that way. So I'll get 8x plus 12 times x squared plus 3x to the 3rd. Okay, the next one, that's the inside function. Outside dy dx. Derivative tangent is secant squared. So it's secant squared blah, blah, blah. Copy the blah, blah, blah. 3x squared. Derivative of the inside, 6x. I don't like this on the back side, so I'm going to write it on the front side. So it's going to be 6x secant squared 3x squared. And that is the answer to all the quiz questions. 10 minutes, perfect.